Our sun is a pretty typical star. It's yellow, so it's not too hot or cold, and it's only a bit above average in size. As a result, we should be extremely thankful to be orbiting around it, as opposed to some of the space objects that we'll be talking about in this video. That's because some of these bad boys can do anything from stretch you into a noodle a single atom wide to completely fry the device that you're watching this video on. But before we get into all that, I would appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so first let's talk about some pretty mundane things. Say, a red dwarf star. These stars are a lot smaller and dimmer than the sun, so if we orbited around one at the same distance we do now, Earth would be so cold it would make the snowball Earth period that took place 600 million years ago look like a tropical paradise. Even if we orbited closer, say a quarter of the radius of Mercury's orbit, things would still not go very well for us. For one thing, planets that orbit this close are almost certainly tidally locked, meaning one side of the planet always faces towards the star, and the other always faces away from the star. As a result, the side that always faces towards the star is like literally blasted by the star's heat, so it's always hot, and the other side, well, never gets warmed up by the star, so it's always cold. It's this phenomenon that causes us to only ever see one side of the moon. But even if we magically had normal rotation, our lives would still be upended by stellar flares. Remember the quarantine event of 1859? You know, that solar flare that, if it had happened today, would have completely wiped out the entire electrical system? Storms like that happen on red dwarfs almost every single day. This would naturally completely screw with the global climate and possibly make it so that any potentially habitable planet around a red dwarf likely has all of its atmosphere and oceans stripped away before life even has a chance to form. Oh wait, did I say red dwarfs were mundane things? Yeah, that's because everything I just described is merely baby talk compared to what's next. Keeping that same red theme, but increasing the diameter by a couple thousand-fold, and you get a red supergiant. These stars are, well, big, with many of them stretching past the orbit of Jupiter and a couple of them even touching the orbit of Saturn. But these are in no way gentle giants. They are nearing the end of their lifespan, with their central core of hydrogen being depleted and running on fusion of other, heavier elements to sustain themselves. The whole time, they are practically blowing off their outer layers in a vicious stellar wind, powerful enough to practically tear off any planet's atmosphere like it's nothing. Finally, after a few thousand years of this, which is nothing in star time scales, the core becomes iron, aka an element which is completely unable to fuse into anything else. And at this point, gravity takes over and the star explodes as a violent supernova, a process which is believed to be one of the most energetic in the entire universe, and that is capable of ending life on Earth even if it's light years away. Once a supernova happens, there are two things that star can become, depending on its mass. If it's a little less massive, it becomes a neutron star, or in other words, a ball of neutrons so densely packed that multiple stars' worth of matter are compressed into the size of your average city. Neutron stars have downright ridiculous physical properties. For one, a teaspoonful of neutron star would weigh more than the entire Himalaya mountain range. Combined, some of these neutron stars rotate at rates of 1 spin per millisecond, which is pretty darn fast considering that the object in question is the mass of a star. And while black holes are the true winners when it comes to gravity, as we'll get to in a moment, neutron stars are nothing to scoff at either. Their escape velocity can be as high as 1/3 the speed of light. But the most extreme properties of neutron stars lie in magnetars, which are so named because, well, they are insanely powerful magnets. These magnetic fields are so powerful, in fact, that if a magnetar was as far from Earth as the moon, pretty much every credit card's data would be instantly wiped. And then the rest of us, because neutron stars are pretty much unsurvivable unless you're, one, accustomed to lifting billions of times your own body weight, and two, can survive million-degree weather. So, yeah. But believe it or not, neutron stars aren't the most extreme thing that you can find. No, that distinction belongs to black holes. In my opinion, they should really be called light holes or matter holes, since nothing, not even light, can escape them. But I digress. Black holes form when the most massive of massive stars die in their own violent supernovae. The matter gets condensed into one infinitely tiny point called the singularity, where pretty much every law of physics and reality breaks down when we try to explain it. Interestingly, if a black hole the mass of our sun replaced the actual sun, we would orbit as normal, since the gravity is the same. We'd just freeze to death. However, if the black hole in question was a supermassive black hole like the one at the center of our Milky Way, things end much sooner, since the gravity is millions of times stronger. We don't know for sure what happens when you approach a black hole, but it is currently believed that its tidal forces would slowly stretch you into an extremely long, atom-thick noodle, a process appropriately known as spaghettification. Yes, it's probably as painful as it sounds. And as for what's inside the event horizon, my guess is as good as yours as to what's down there. And for those clinging to hope that these existential monstrosities can only be found in math equations, we have actual pictures of black holes now, so these things are definitely real. Thankfully, the nearest black hole of significant size is thousands of light years away, so we shouldn't worry. Yet. And that's everything for now. Let me know if you want to make a part 2, where I cover even more extreme objects in this universe, and what would happen if you got too close to one. Until then, I'd appreciate you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks, and have a great rest of your day.